After we posted Lloyd Stovall's take on Maxwell Chikumbutso technology, a number of experts in the field reached out to Lloyd and got into this heated debate. Scythe Technologies watched the video too, and their response was crazy. We will talk about it later. For now, listen to this and let me know what you think about it.
You've just violated a fundamental. You cannot create power from nothing. I guarantee you, I will put my life on the line that you have less power coming out than you put in. Is lower than your power in.
But first of all, it's producing more energy out than you're putting in, technically, and they don't like that. So they're trying to suppress it, and they do everything they can to suppress that. Okay,
I'm gonna have to push back on that as being more energy out than in, because again, once you take into the pulse width, when you take in the time it takes to create that really high spike, what you're doing is time is the denominator in that equation. So if you shrink time down to almost zero, that value gets erroneously large. Like, it's because of the time being so small. So that's why I was asking about the time period. That's what makes it large.
Okay.
So, but you're not getting more out than you put in. Okay. You're not getting that.
Let me break that down. Okay. The Mosfets are very efficient of utilizing energy. So what you're doing is that because of what it's made out of, it creates back EMF. That means it switches from north to south. When you switch that at high speeds, it does act like a generator. It's actually creating these spikes. That's what we.
Can you explain how EMF translates to generator?
Electromagnetic waves is in a motor. The magnet.
I know, but how does the EMF, electromotive force, translate to generator?
A generator produces EMF, back EMF, and forward EMF. Electromagnetic waves. That's the whole concept of motor. It means that it creates electricity when you have it back EMF, which causes the spike. Anything that's creating the electromagnetic waves, that means magnets and electricity, you're producing or generating power. The back EMF means that it's trying to also generate as well as make a motor move. So it's trying to go both ways, and one force has to overcome the other. So
that's graceful. That's egregiously incorrect. Where are amps in this conversation? Danny, I know you were going to bring that up. Like, so the EMF and motors and generate I'm sorry, Danny, you got it, but please don't let us slide past that point, Identity, because that's...
Do me a favor and go to the last video I did. Look at the demonstration that we did where we show how we take a speaker that cannot even run an LED light, and when you put an LED light and you tap it, because of the rapid tapping, it causes the LED to light up temporarily and go out really fast.
There's the time period I was talking about.
Okay. Wait. Let me finish. Wait a minute. This is why we don't understand. So if you finish out the video, it's a real short first part.
Before you go to your video, though, I would like you to discuss EMF specifically, not electromagnetic waves. EMF and its relationship to motors. Specifically, you said generators. And where is current at in that conversation?
Okay, let me slow down. And what I'm trying to get to you, if you look at the example first, not only did it answer the question on how we can use and utilize those spikes, if you look at...
I know.
Okay, wait. Let me finish, because everybody, if you cut the information off, what we end up doing is that you only using the technology that you're used to. So if you're used to a technology and you're versed in the technology that you're used to, and someone's trying to show you something new, and you go, no, that doesn't make sense because you're going back to the old way. So I'm introducing to you how those spikes can be used. If you watch that and I says, well, did that solve the problem? Then we can move forward, because that is working on back EMF spikes. And it's working as a generator. The example that I put in there and actually using those spikes, it's just perfect. That's why I just say, people, if you go to the video and watch the first little part of that and see the things, it just blows a person's mind that someone would actually use it in that manner.
So EMF and generators. Can you just elaborate on that?
Motors work on electromagnetic waves. That means energy. Okay, that's what it comes from the magnet.
So I'm confused. Why are you saying electromagnetic waves, but you're talking about EMF?
Because
I'm confused.
Because you in a motor you have a magnet and you have wire, right? When that wire
while you're explaining that, can you send a link or something to your video? I can at least have it.
I see the confusion.
Hold on, because I want to make sure I want to see what he's talking about, because it might be a learning moment in there. Does anybody know where the video is? I don't know even where to look.
Go to Lloyd Stovall and go to YouTube. My name.
Okay, so your name. Okay.
Yes.
All right, go ahead. Keep talking. I'll do it in the back.
Okay, so you in a motor, you have a coil wire that's spinning in a.
No, I get that, but I'm confused in the way you're describing it, brother. When you're saying EMF, and then you're saying electromagnetic waves. So you're saying electromagnetic waves include magnetism, radio waves.
Okay.
You know what I'm saying?
So you got magnets putting.
That's a confusion there. That's why we're confused, because you keep saying EMF and then you're saying electromagnetic waves.
Okay, so
electromagnetic waves.
Magnets put out magnetism, right?
No, magnets produce a magnetic field.
Okay, is that a wave?
It's a magnetic field.
Yes, we know.
It is the magnetic field.
Okay, but you're saying field, but the way they describe it, a field is also a wave, right?
No, because
so you got a field without a wave.
Field theory.
Yes.
So
yes.
Yeah, it's not one to one. It's not the same thing when you're talking about a magnetic field.
Brother, we live within the Earth's gravitational field.
Right.
The gravitational field does not define gravity.
Yes, but in the field, the magnetic field, I'm asking, is that also a wave?
Yes, it is a wave, technically, but it has nothing to do with the electromagnetic waves that you're talking about. You talk electromagnetic wave, you're talking about a spectrum, an energy spectrum.
Okay,
magnetic field, you're talking about a single entity.
So no, what I'm saying is that when you put electricity into the wire, and that wire is spinning into that magnet field that you got, you just introduce electricity and magnetism, electromagnetic field or waves, because you're spinning it, and the frequency comes in on the cycle of the motor spinning the wire in the magnetic field.
No offense, brother, that's gravely incorrect.
Okay, so then, like I said, look at the video and explain how I did that. Explain how that was possible.
I'm sure we could, but your experimentation doesn't rule out the need for language. You know what I mean? If we're describing, do you know what a magnetic field is? If I tell you we're using a hexagonal screwdriver, and then I pass you a flathead, would that make sense to you? And then I tell you go watch my video, would that make sense to you?
Well, again, what you're saying is that you don't. Wait a minute. You
have a hexagonal screw.
Wait a minute. You're making a point, and I get your point. But the whole point is that every scientist who really gets into the field has a point where he says, if you don't describe something in my terms, I won't accept it. So guess what? You have scientists or inventors like Nikola Tesla who has created things outside that realm, and you say, I dismiss it. So what we do?
Tesla did not create anything outside of that realm. George Westinghouse invested thousands of dollars into Nikola Tesla.
Okay, so you really thought he was going to transmit energy over the line, to antenna to antenna? You thought he was going to actually do that? It's impossible.
Right now we're doing it. Right now
we're doing that, man.
You're not transferring. You're not transferring amps over the way. That's impossible to transfer.
All right. So you see how you're throwing the words in? What is an amp then? Because I'm confused. Nobody said the
current. Current.
We're not discussing current. What do you
current can't be transmitted. That's what we're talking about. Amps can't be transmitted. The current can.
What are you calling when you say current can't be transmitted? If you got struck by lightning, what would that be called?
High voltage spikes.
And what would kill you with also part of that lightning? What's the average amperage in lightning? Because what you just said was another egregiously incorrect. And lightning has amp.
Yes, lightning has amps.
So therefore, you can get lightning from something out of the air. So that was incorrect what you just said.
But lightning is a physical wave. It's not just unseen. So
no, lightning is the plasma.
Yes, exactly. So therefore, it's more at the light spectrum than it is just a regular wave being transmitted.
No. So, brother, we want us to move forward. But the challenge is, we want to understand your definition. So if you're saying, because you're using words that we use, but you're using it in your own way, and so we're just.
Well, I'm using what every paper has wrote, that they said Nikola Tesla's antenna would never work because you cannot transfer amps long distance. That's what they wrote in every picture.
Why are we talking about transferring amps in long distance? Right now we want to understand, how are you moving a motor without amps? Because you just talked about a generator using electromagnetic waves.
You don't transfer amps, bro. You transfer current.
No,
that's what I just said. That's what I was saying. I said post current. That's what you're transferring. It turns it into.
Why would you be transferring current?
No, the way he's saying it,
the logic makes no sense.
Yeah, like saying you transfer amps, the current that you're transferring
is post current. And I did say in the beginning that current is different than amps. They're two different phenomena.
So I can see he's using the terms, but he's using it at his own volition. Like he's not.
Yeah, he's pulling a wallet.
I'm okay with you like transferring the knowledge, for lack of a better term here. I'm okay with you transferring the knowledge, but understand, if you're not reaching me, if I don't understand, I would at least hope that you want to try to explain it in a different manner that I can. You can't just say, hey, you just don't get it. That's not a good back and forth in the conversation. So when you're using these terms, sometimes you're using them specifically, and then other times you're using them as like a placeholder. Wave is a field. Wait a minute, how are you that nonchalant with that? But then you say current and amp. You're very specific with that. So you're like in and out with what you're standing on. So that's the confusion for me. And I'm sure other people are hearing it too.
And that's the confusion. That's the confusion that they've always put on there, because they have a specific way you have to tell the scientists, the people who are putting out this information.
I told you, scientists today know.
They have a specific way you must say everything, and if you don't say it in those specific sequence, then they have a problem. They say, "Oh, this doesn't work."
Do you understand why that is true, though? Do you understand why that's true?
And I'm asking you, do you understand why that's not true? Because you can't advance if you don't try new things.
I will explain to you why it is true. I will explain to you why it is true. Because if I explain it the exact way I did the experiment to you, you can repeat it the exact same way I did it. The same units, the same components, the same circuit, the same. I don't need to change the language. This is how I know it works. That LED turns on because I put 3.7 volts on it, and I limited the current with a series resistor. Now, if I told you the current is a wave, and that's why it's important. It's to transfer the knowledge. So I ain't not going to stand here and say that we shouldn't be speaking specifically. We should be.
Okay.
That was very precise and straightforward, easy to comprehend.
So why does the experiment work? Explain it.
What experiment?
See, again, that's why we broke down, because you didn't go.
Well, you have a bunch of videos. I don't know.
No, it was the latest video out there, and right in the book it shows a water droplet dropping into the water to explain transit energy. This is the topic that no one wants to touch.
13-minute video, you mean?
Yeah, but you only had to watch the first few minutes.
But to my understanding, again, if you're saying the coil is dissipated of all potential energy,
yes,
and then somehow that light turns on, you've just violated a fundamental. You cannot create power from nothing. Like, you can't create energy from nothing. So there had to have been some conversion. So again, that's the part where you're going to have to show me you started at 0 and you ended up at 5.
Okay.
So you would get Nobel Prize for this.
Okay, and we'll start with that. So the word transient energy is how it's spelled. Tell me the definition of it.
Oh boy. Transient energy?
Yes.
Oh, he's asking a question. I was letting him talk.
Isn't that isn't that like kinetic energy? Energy that is being utilized or in motion or work?
No, these are spikes that happen randomly in electronics and what's.
I already got a page that I want to show for that. I actually have that.
Can you read a definition of it then? Because you're saying no.
Transient voltage, often referred to as voltage transients or electrical surges. That's kind of what it is. Electrical surge is a sudden, short-lived spike in voltage levels within an electrical circuit. So this is why it's damaging to circuits, because the voltage is extremely high relative to where the operating of the material can handle.
Yes.
So if you're talking Mosfets.
Yes.
I'm sorry, go ahead.
One reason why you would imply like fuses and stuff.
Yes.
And also there's a circuit design. You can actually have shunt capacitance that actually resists.
Exactly.
So you can actually control it that way as well. But the point is, it's transient. It's you know what a really good example of it is? Electrostatic.
Mm-hmm.
Like when you touch a doorknob, it's really high and it shocks you, but it's so short-lived, it's not going to kill you. You feel it, yes, and it is extremely high relative to the doorknob's potential, like essentially 0. But because of that transfer, it's immediate. So that's why I'm asking about the harnessing part, because if it's an immediate, you're going to need a bunch of those just to collect that energy.
Okay.
You need a bunch of them.
That's why it was so important.
If you have a bunch of them.
Wait a minute. That's why it was.
You get around not damaging your system. These signals are detrimental to circuit design.
Yes. Exactly. That's why it was so important for you to look at the example. So you've already covered the transient energy, and we are in total agreement on exactly what those are. Now we're getting to the point, how did we harness them? I think Nikola Tesla, I know Nikola Tesla was trying to say the same thing. He says, if you want to know the whole universe, think on the lines of vibration, frequency, and energy. And he just left it as that. So it was so open-ended. And when we apply those things to the circuits that we're doing, we start to see that the phenomena that they said they couldn't control those spikes is not true. They don't want us using those spikes because they don't have an explanation for what transit energy actually is. So they discount it. And when you go to any AI and what's, and they say, we discount it. We understand that we know what the phenomena is, but we discount it. So I was saying, if you discount something in science, either you have to go so far into the future for us to start looking at it again, or it takes open-minded people to sit down and say, okay, let's look at this, find out as best we can what it is and how we can harness it, and then you made something new.
So again, like, the only pushback I really have is it's too short-lived to be useful. High voltage doesn't mean high power, for one. Because it's high voltage, doesn't matter. If it's high current, doesn't matter on its own. It's the power that matters. That's what we transfer. Not the current, not the voltage. We transfer the power through different mediums. So if you're telling me that the voltage spikes, but the time frame is so minuscule, what am I going to use that for if it averages out to essentially zero?
Okay.
Like, that's, if it's not a constant signal for me to capture every time. If it's not constant, then what am I going to use it for other than, like, damaging my circuit, for one?
Okay, and this is where frequency comes in.
See, if your input energy was from a natural energy source like solar, wind, or water, or otherwise, then it would actually make sense.
Wait a minute, did you put me on mute? I just said my energy comes from solar.
Oh, so you're using solar energy to run on it.
Okay, so let me go through the explanation again.
So you're using solar energy to pass that through the MOSFET.
Yes.
The MOSFET. And then
transfer it over to current.
Yeah, to power LED bulbs that then use as source for a secondary solar panels that's gonna now produce electricity for you.
Okay, that's why I'm asking. Wait a minute.
Wouldn't it be more efficient to just set up the secondary solar panel outside and just use solar panel and done?
Again, because you didn't hear.
Unless you're telling me that maths doesn't count, because according to the physics. Not the physics.
Did you hear the explanation on how I set up this
electricity?
Did you hear this?
You're gonna be losing current. You're gonna be losing energy somewhere.
Okay. Yes, we're losing energy somewhere. But what I'm saying is, if you didn't hear what I said, then you can never understand.
I heard you.
Okay. So how many solar panels do we have?
Alright.
My bad, y'all. My bad.
2 in your basement and the ones that you got outside.
That's what you're misunderstanding. That's our disconnect right there. Okay? I'm saying let's go over the one unit. I take LED lights, wrap them around foam core. And when you wrap them around a foam core, you have 2 sides. Then I sandwich that LED lights, which only runs on 5 volts. Okay? And we put them between the 2 20-watt solar panels. We get only voltage. We lose our amps because of the LED light being not an intense light. If you do that, we now have 17 volts with 2 different sides, the top and bottom. So we have 17 volts. If you put that 17 volts into that MOSFET as the power source, that means the bottom one, and then take the top source, this is where you're losing power, and put it in for triggering the MOSFET to trigger at high speeds. Okay, you're now transferring.
I'm looking at it a little late. What's top and bottom of a MOSFET?
This is what the energy thing. You have to go through the rest of the video. That is my system, and the only thing that we're doing is we're just getting our current back using pulse current. And everything you just said, you've already guys about a minute, we're saying the same thing. You're losing energy, but it's coming from a 5-volt source. The energy, it comes with the efficient of the LED lights. So
I guarantee you the voltage times the current coming in is higher than the voltage times the current going out.
No, because the the current going on is...
Brother, it has to.
No.
If you prove that that is not right, then again, you are going to be the only man to ever experience this, and you should get a prize for this. If you can tell me that that statement is true, you get more power out than you
No,
put
we
in.
don't get more power. We get transfer power.
Well, again, wait a minute, because when I said voltage times amps in is greater than voltage times amps out, what that translates to, power in is greater than power out.
No.
That's all I said.
I understand,
That's
but
all
I'm saying is that it's a transfer energy. I'm transferring high voltage spikes, and I'm getting pulse current out, and the pulse current is higher than what the solar panels will produce, because they only
You're not transferring voltage, brother.
What do you mean I'm not putting voltage in it?
You're transferring energy. Energy gets transferred. Not voltage, not amps, not as individuals.
So what would
it's a power in, and hold on. It is a power in, power out. That's why you cannot just say voltage, because it depends on what that amperage is. I can get high current, but a really low voltage. Power is crap.
Yeah.
Like it's a duality. You can't just say voltage. I put in a voltage and I get a current out. Yeah, that's nice, but what is your power in versus power out? I guarantee you, I will put my life on the line that you have less power coming out than you put in. So with that said, you don't lose any. The only thing you lose really is energy through the transfer, the conversion. It's always going to lose. If you show you get more power in, more power out than you put in, you deserve a prize, brother.
Okay, so here's the thing that you disconnect. If I'm rapidly putting high speed switching in this, isn't that a form of energy?
You're putting energy into the system. Yes, I'm following.
Okay, so I'm saying is if you're taking a frequency that's moving at a sonic speed, okay, and you're putting it into that MOSFET, am I going to get the same amount of current, which is shown on the solar panels, which is 1 amp? Okay, 1 amp. We're rounding it off, 1 amp. Are you saying that if we're pulsing that MOSFET at sonic speed, okay, that is only going to produce 1 amp of pulse current out?
It depends.
Okay, that's all. So we at least got there. We at least got there.
But yes, but you can also have it where it gives you more current. You can also have it where it gives you less current. That's why I said it depends. But at the end of the day, you're not going to get more power out.
I didn't say that. You keep saying that.
So why are we saying it's a monumental thing that we're getting a higher current?
We're not. We're not. I keep saying that over and over that we're not.
You said current, voltage in, current out. MOSFET. That's how it operates.
Yes, but we're transferring voltage just like a transformer. You either step it down or you step it up. You can't have both on both ends. You're not going to have higher amps or...
Well, you can, but you would use something other than a MOSFET.
Okay, so all I'm asking is that we put high voltage in from the solar panels.
Yeah.
And I told you that I'm not a technician. I'm a person who tinkers with stuff, redo things to try to explain it to people who really don't have any idea about it. So I said, if I start working on these things, I can understand them better. So that's all I do is this private research for my private librarian or library, as you say. But the whole point is that I did this for experimental purposes. But when you explain what someone else is trying to do because he's trying to make a fast buck and you expose that, it went viral. It went viral, and I haven't changed my stance on what I said. We both agree on exactly what this MOSFETs do in the system that I work. we all agree on that. So the whole point was.
Respectfully, I don't have, like I said, this is my space, and I don't expect everybody to know all this stuff, but I don't do this as a hobby. I do this as a career, so that it's not me just shooting in the dark. I do this. I build Mosfets. I build amplifiers. I build circuits, systems, efficiency. I know the nuances of just what that MOSFET can do. Metal oxide semiconductor field effect transistor. That's what MOSFET means. And that just means you put a bias on the gate and the drain current increases because there's a charge carrier current that's in the middle of the device. It heats up because there's resistance on that line. That's inefficient. Your voltage on the drain, and you're grounding the source. All of these things, I know the science of it, not just theoretically, but actually using it, implementing it, and optimizing it. So when you talk about using that spike, and I'm saying to you, I know that spike very well because it's a problem in RF design. It is a problem because it rings within the system, and certain components fail when that ring hits it. So you got to be able to filter it. How do you filter it? You better know the frequency, you better know the amplitude, you better know how to use it. Do you use shunt capacitance? Do you do parasitic capacitance? Increase, decrease that? CDS, CGS, all those things, they play a major role in all of that to eliminate that. Because technically, in how we design, it's useless and damaging. And that's why we don't use it, because in order to use it, you got to have a system large enough to even sustain that large voltage pulse. It's a large value. That's why it's damaging. And that's why you want to make sure it doesn't get near your system. So when you're talking small electronics, electrostatics destroy small electronics.
Unless you use.
It's just a known fact.
And let's work out these ideas. But my intention was to just do this as experiment for my company and talk about these things, and all I get is people saying things, you know, if you go through my videos, oh, you can't plug an inverter on in itself. So I made a whole video that says, this guy says, if I take this plug, which is in a loop, and I plug it into the system of this inverter, that this inverter is going to blow up. So when I do it and the inverter don't blow up, then everybody comes at you, well, it'll eventually run down. That wasn't the point of it. You said it was impossible. Then when I proved it wasn't impossible, you go jump off on a new thing. And I says, this is what we saying. We are sitting and trying to come up with things new. And you have to break eggs to make something new. So maybe I'm running in an inefficient way, but my system does work, and other people said it works. Now, how long it works, that's what it's still running over 8 years, and it's running in my basement today, okay? And it's running my whole household, okay? So, yes, because